Good day, everyone, and thank you for attendance at this symposium for today, the 2nd of September of the present year. Today we'll be looking at the results of the thesis project that was done by Mr. Nathaniel Castillo as a student in the Natural Resource Management Program at the University of Belize. Was his thesis advisor. I'm the lecturer at the Department of Science at UB. So the name of this presentation is the assessment of seasonal variation in groundwater quality, and was focused on the City of Belmopan. The layout of this presentation consists of the introduction, the purpose of study, the methodology, the results discussion, and that of the conclusion. Belize tend to be well blessed with water resource on an yearly basis, and the source for water comes from the surface water, for example, rivers, streams, and also from groundwater, from aquifers, or from wells that are dug to get access to groundwater. No, water resource is used for agriculture purpose, for industrial purpose, and for domestic purpose. Now, within the realm of the domestic purpose, there is for drinking water and also for the use in the household by people. Now, in terms of this project that was focused on determining a preliminary assessment of the quality of groundwater via dugout wells, and this includes artisanal wells within the area of the City of Belmopan. So the main purpose of this study was to present the preliminary assessment of the quality of water to determine if there's a change within the parameters of physical, chemical, and microbial with seasonal change. These seasonal changes have to do with the dry and wet season that occurs here in Belize. You can see there on this slide the list of chemical parameters, the list of physical parameters, and also the microbial parameters. And for methodology, the flow chart there shows whereby there was the selection of sites, and this were the choosing of the wells, okay? And then we did the 3 types of assessment. Now, the physical assessment was done on site. The chemical assessments were done in the laboratory at UB. And then the microbial assessment was done at the National Water Quality Lab under the Ministry of Health and Wellness. And obviously, in order to get it before getting the samples to the lab, it had to be collected, right? And that was a tedious job that definitely Mr. Castillo, myself, and other students and volunteers participated in collection of samples. And then we went on to do the analysis, then reporting of the results, and then the recommendation.
Okay, everybody, so I will display the study map. So this map shows all the sample sites that were selected in this study. Previously, from what was assessed, we found a population of 45 wells. This is not all the wells that are within Belmopan. These are just the wells that we located based on time and resources. And given that this was what was known, we used this as the baseline to sort of guide this new assessment, which was a continuation from an initial inventory. So from the total of 45 wells, we created a sample size of 18 wells that spread across the city of Belmopan. So areas that was involved in this study was Las Flores, San Martin, Salvapan, and Maya Mopan. And here you could see the different images from the wells that we actually saw at these different sites. The codes are Las Flores for LF, San Martin is SM, SP is Salvapan, and MM is Maya Mopan. So just to elaborate more onto the methodology that Mr. Raquez said, using the YSI to conduct physical parameters, we assess altitude, ammonium, conductivity, depth, dissolved oxygen, pH, temperature, and total dissolved solids. In terms of chemical parameters, we assess chlorine, iron, nitrates, phosphates, and turbidity. In terms of microbial assessments, we looked at E. coli, total coliforms, and fecal coliforms. From the data that was collected, you could see here the physio-chemical parameters for both wet season and dry season in the table above. And parameters that stood out to us, there were 6 parameters that stood out to us. So firstly, we're looking at total dissolved solids, where based on the WHO recommendations, you should have less than 500 milligrams per liter. And in this case, some of the populations within this study was significantly above this range, especially in the dry season. Another parameter that stood out to us was conductivity, which is measured in microsiemens per centimeter. And WHO recommendation standard level for this is anything less than 400 microsiemens per centimeter. In this case, we had about 80% of the sample population above the WHO recommended standards. Following this was nitrates. The WHO recommended standards for drinking water is anything less than 5 milligrams per liter. And here we had 20% of the population in really high numbers. That is well above the acceptable limit. Following this, we had phosphates as well, where some of the sites were above the WHO recommended limits. The WHO recommended limits for phosphate is anything below 0.5 milligrams per liter is safe water. Another parameter that stood out was iron, where the WHO recommended limit is anything below 0.2 milligrams per liter. And here we had about 40% of the population well above this limit that was recorded. Lastly was turbidity. For this, only 20% of the population was above the WHO recommended limit, and WHO recommends anything below 5 NTUs is okay. So now looking at the microbial parameters, here you could see the results that we got. And because not all parameters were tested at the same given time, we had to go with recommendations from our friends from the Ministry of Health and Wellness Center to focus mainly on E. coli and fecal coliforms because these microbes share a positive correlation between one another. We did not focus on total coliforms because this is a parameter you would look at if it was treated water. However, we're classifying this water as untreated due to the frequency at which the wells are chlorinated. So Here you could see that positive correlation between fecal coliforms and E. coli. So moving into how these microbes correspond with water quality parameters, you could see in the table above how E. coli has a negative correlation between nitrates and total dissolved solids. However, it does have a positive correlation within phosphates. So this means that if phosphates are present in the water, you will have a high number of E. coli. For fecal coliform, we have positive correlations for all three parameters, which is nitrates, total dissolved solids, and phosphates. So if any of these parameters are present, you will have a high percentage of fecal coliform present in the water. Now, we're moving into the physio-chemical parameters and how these parameters change over time. So to assess this, we use a one-way ANOVA analysis to look at the p-values, and if the p-values are less than alpha, in this case that is 0.05, then that indicates to us that yes, indeed, there is a significant change in this specific physiochemical parameter over both wet season and dry season. So for this, two parameters stood out to us, and that is pH1, where we got a p-value of 0.01, which is less than alpha. So it doesn't indicate a significant change. And also dissolved oxygen percentage, which gave us a p-value of 0.04, which is less than alpha. And this indicates that, yes, there is a significant change within this water quality parameter over the two seasons. So in conclusion, this information is baseline data that could be used by the National Hydrological Service, the University of Belize, if there's any students who would want to further this study, as well as the Ministry of Health and Wellness, because the location, status, and the change in water quality of these wells are directly in the mandate of the National Hydrological Service and the Ministry of Health and Wellness. This is all needed in order to create an inventory of water wells for the entire country of Belize. So at least they have a head start in the city of Belmopan. Now moving into what we could conclude for seasonal variation, we can say that the seasonal variation has a significant effect on the concentration of certain parameters, as was seen through the analysis of a p-value. And in this case, both dissolved oxygen percentage and pH had a very big change during the change in seasons. Lastly, the results indicated that majority of the physiochemical parameters were within their acceptable limits, except for iron, total dissolved solids, conductivity, and turbidity. One last recommendation that we would want to give is that based on the high percentage of microbes that were in the water, it's our recommendation to do some form of pre-treatment if you would want to use the water for any domestic activities. Some form of pre-treatment is needed, and a cheap and effective form of doing this is through the use of chlorine. So we suggest that these entities should monitor the groundwater quality and assess occasionally to prevent any high concentrations of microbes to occur. So with that, everybody, we say thank you and have a wonderful day.